So we are going to be starting in Chapter 5 if you decided to buy the textbook. The reason why we're starting in Chapter 5 versus Chapter 1 is in Chapter 5 we talk about the normal distribution. The normal distribution is a tool that we're going to be using throughout statistics. However, few students have been exposed to the normal distribution before. So the goal in this set of notes is to get us to understand this tool. That way when we start applying it a little bit later, you've already had some practice by using this tool. In our first video, we're going to talk about how the standard deviation can be used as a ruler. And one course thing that we will do is define what a standard deviation is. But we're going to start by looking at a question that we would like to answer. Suppose we have two children who are going to do multiplication flashcards. We're going to calculate how many problems they got correct in 1 minute. Our goal is to figure out who is better at multiplication. Now the answer to this question will probably seem obvious, so what would that be? Well, we would probably think whoever got more questions correct is better. So if one student gets 20 right, one gets 30 right, the student that got 30 correct is going to be the person who is better. However, I have some more information about these children. Quinn is 8 years old and Tanner is 10 years old. So what do you think now about figuring out who is better at multiplication? So the first question we might want to understand is, does age matter? It probably matters how old these people are that we're looking at. So when does a student usually first learn any ideas of multiplication? Probably when they're about 8 years old. So Quinn is just being introduced to multiplication versus Tanner, who is 10, has been doing multiplication for a couple of years at this point. So this makes it a little bit harder to decide because age seems to have an impact here. So age is probably a factor here. So let's look at some more information we have here about some 8 and 10-year-olds. So looking at how many they get correct in 1 minute, we found the average or the mean for 8-year-olds was 34 questions in a minute, and for 10-year-olds it was 61 questions in a minute. Then I've also given you the standard deviation of the number of questions correct in 1 minute for each age group. So let's first make sure we feel clear about what a mean is and what a standard deviation is. So what is a mean? Well, this is one that we've generally seen before this course. This is the idea of the average. So like we add up all the numbers together and divide by how many we have. Another way of thinking about the mean is it's sort of what we would expect. It's the expected value we would get. So looking at the difference between the means for 8-year-olds and 10-year-olds, it probably makes pretty good intuitive sense that on average, 10-year-olds are getting quite a few more questions correct in 1 minute than 8-year-olds, simply because they've been doing multiplication much longer than those 8-year-olds. Now, what is a standard deviation? A standard deviation gives us the idea of the typical distance from the mean. Now, what do I really mean by that? Well, it gives us an idea of how spread out the values are, sort of what we would give or take. So, with the average being 34 questions, right, for the 8-year-olds, standard deviation is 10, kind of would mean then that the typical student would score between about 24 questions, which is 10 below the mean, to 44 questions, which is 10 above the mean. So it kind of gives me this range instead of just a number for the mean for an individual student. Now, looking at the idea of the standard deviation of 8-year-olds being higher than it is for the 10-year-olds, let's talk about why that would be true here. What that would mean is that 8-year-olds tend to be more spread out than 10-year-olds. Okay, what that really means is that 8-year-olds are a little bit more all over the place. That is, there are some students not getting very many questions right, but there are some students who are doing quite well and getting quite a few questions right. Or in a sense, they have a larger range in their abilities at the age of 8 because it's new to them. Versus at 10-year-olds, hopefully those that were a little bit further behind are catching up, and so they're less spread out at that point. So that's the idea of what standard deviation is. So now let's look at how many questions Quinn and Tanner got correct in 1 minute. So Quinn got 56 questions correct, and Tanner got 74 questions correct. So who was better? Well, let's look at Quinn. So Quinn is 8. On average, 8-year-olds get 34 questions correct, and she got 56. So Quinn got more questions correct than on average. Well, looking at Tanner, Tanner is 10. On average, they get 61 questions correct, and he got more than that right. So they both did better than the mean. And that's even taken into account their age. But the one thing I haven't figured out how to use yet is, I looked at the fact they have these different means, but how do I use the fact that they have different standard deviations? So how can we use this fact? Well, what we need is a way to compare these values on the same scale. The way we do this is through a process called standardization. So let's talk about how we actually standardize a value first, just using terms that we understand, and then taking into account the symbols attached to it. We're going to start by doing exactly what we were doing before, just now putting it in a mathematical term. We're going to take our observation, how many questions that individual student got correct, and compare them to their mean. So if I were to do this for our two students here, what I can see is if I took 56 minus my 34 to look at Quinn, that would tell me she got 22 more questions right than average. For Tanner, I would do 74 minus 61, since that's his mean, and find out that, well, he got 13 more questions right than average. So I'm just really comparing them to the average at first, which is exactly what we did down here. So now how do I really take into account this different standard deviation? Well, what we do is we scale by it. So we take this difference that we just found, and then we divide by the standard deviation. When I do this, I give this a new symbol, and this is going to be called a z, or a z-score. Symbolically, or what you're also going to be seeing on your formula sheet, is for the observation, we use the symbol y. For the mean, we use the Greek letter mu. And for the standard deviation, we use the Greek letter sigma, the lowercase sigma. And you'll see those symbols right here. So first, as a side note, knowing you're going to get a formula sheet for all your quizzes and tests that you're going to take, making sure you feel comfortable with those symbols is going to be important. So right now we don't have a lot of symbols, but we will keep adding to it. So make sure you're getting comfortable with the symbols that we're using. So once I've done this calculation, what is it actually telling me? Well, let's actually first talk about the units attached to this z. So what z tells us is the number of standard deviations So its units are number of standard deviations. And observation is from the mean. So unit-wise, number of standard deviations from the mean. But it also tells us and in which direction. That is, did they get more questions correct than the mean, or less questions correct than the mean. So let's talk about how I know the directions attached to it. So when I get a z-score, I can get a positive number for this, I can get a negative number for this, or I can get a 0. If I get a positive number, so first, standard deviation will always be a positive number, so I can never be dividing by a negative number here. So that sign is going to be based upon the numerator. So the way I'm going to get a positive number is if my observation is bigger than my mean. So that would mean here the student would score more questions correct than the average. So to get a negative number, then, this observation would have to be smaller than the mean. And the only way that I can get 0 is if the observation equals the mean. And so if the observation were to equal the mean, I got exactly what I expected. And so for when we're trying to get these new z values, we sort of need something to compare them to. And so this 0 sort of becomes our important number, because that would mean I got exactly what I expected. So when I'm talking about what I should compare this to, then the z-scores have a mean of 0. And this 0 is going to be a very big comparison number here for us. So now we actually have the information to be able to answer our question about these two students with who did better with the flashcards. So we're going to be using this formula to help us, but at first it might be nice to think about, well, what am I going to be looking for in this number before I've done the calculation? So let's first talk about what better even means here. Well, early on we said the more they got correct, the better. Right, so here higher is better when it comes to the number of flashcards we got correct in 1 minute. What that's also going to tell me then is that I want my z to be higher. So the higher the z-score, the better the student did. So now I can actually do the math here for my two students. So let's do it for Quinn first. So Quinn was our 8-year-old. She got 56 questions correct that we saw right here. Right, since she is 8 years old, we're going to be using the 8-year-old mean and the 8-year-old standard deviation. So for Quinn, we're going to take 56 minus the 34 and divide by 10. Which then gives us a z-score of 2.20. So first, what that number would mean, so it's positive, so her observation was higher than the mean, and this tells me that she did 2.2 standard deviations better than the mean. Better since it was higher. Now we can do the same thing for Tanner, but we have to remember, of course, that Tanner is 10 years old. So Tanner got 74 correct. His corresponding mean is 61, and his standard deviation is 7. So for his z-score, we'll take the 74 minus the 61 over 7. And we get 1.86 when we do that in our calculator. Again, his value is positive, telling us that he did better or higher than the mean here. Now the units, again, are number of standard deviations. So he did 1.86 standard deviations better than the mean. So they both did better than the mean. But whose score was even more higher than the other, right? So we already said the higher the Z then, the better the student did. So for that reason, Quinn has done better. So Quinn did better because she was more standard deviations above the mean. In the next video, we're going to do a couple more examples of looking up these z-scores, because maybe sometimes we're not always looking for who did better, or maybe higher isn't always better. So we're looking at a couple more examples to see how we can use those contexts to answer the same type of question.